Yes,
Yeah,
sir,
yeah.
you are audible, sir.
Perfect, perfect.
So let us start our session by 2:30, sir.
Sure, sir. That should be fine. Yeah.
Okay. Daniel, sir. The participant about to join, sir. So let us wait for another 3 or 4 minutes.
Should be fine, sir. Perfectly fine.
Good afternoon, one and all here. Welcome to the session 9. I welcome Mr. Daniel Amos, who is the speaker of this session, for the title Additive Manufacturing Forms. Let me introduce Mr. Daniel. Mr. Daniel Amos has got close to a decade of experience with the industrial 3D printing and or additive manufacturing. Mr. Daniel Amos is currently the Director India Operations for Delta Rapid 3D. Delta Rapid 3D is a company focused primarily on the industrial plastic, metal, and ceramic 3D printing applications with AM technologies like selective laser solidification, direct metal laser solidification, direct energy deposition, etc. The company is an authorized distributor for the 3D printing major like Messrs. EOS, GmbH, BM France, Lithos, Materialize, Sintrac, etc. in India. Mr. Daniel Amos is a trained and certified 3D printing and additive manufacturing consultant. He has also been closely associated with the professors who are in the field of CAD/CAM rapid prototyping, industrial 3D printing, and DFAM, design for additive manufacturing field for nearly 30 years. In the last 7 years, he has been closely associated with all major areas of industrial additive manufacturing technologies for aerospace, defense, medical, tooling, automotive, and educational industries. His areas of expertise has been in jointly setting up the industrial additive manufacturing and 3D printing projects and business models for various major manufacturing companies and R&D educational industries in the country. Since 2014, Mr. Daniel Amos has been a partner with the EOS GmbH India for all their industrial additive manufacturing solutions. I welcome you for this session, sir. I handed over mic to you.
Thank you so much, sir. So, it's my pleasure to be a part of this entire event organized by Mahalingam Institute and also jointly with the All India Council for Technical Education. And also welcome all the participants who are there. And definitely know it's a session after the lunch and should be a quite challenging session, but I'll do my best to see how interesting it could be for all of us to take this time forward. I'm just trying to share my screen, so please let me know if you're able to see my screen, and then we can proceed forward. So is it possible to see my screen?
Yes, sir.
Fine. Sure. So today's session, we're going to look at the adoption of AM digital transformation with industrial additive manufacturing tools along with Printfirm. So I'll be running through the entire session in terms of what is this digital transformation that we're talking about and how the industrial applications are going to be of help to us. So, sorry, did someone say something? Sure.
So, no, sir. You can proceed.
Okay, fine. So looking at Delta Rapid 3D, we are into the metal, ceramics, and also the plastic technology. And also we work on MMCs, metal matrix composites, for various different applications. So Delta Rapid is been part with few of these companies on the design aspect, the print aspect, and also the post-processing aspects of it. So we work on a holistic solution providing, not just on printing alone, because printing does not play a major role when we are looking at 3D printing process, so which we will come to it in a shorter span of time in the coming slides. So we deal with a complete whole process chain of 3D printing from design to the post-production or post-processing in the 3D printing. So we closely work with EOS for most of these industrial applications, and EOS has got quite a bit of experience in the industrial additive manufacturing field, both on polymer and also on the metal. And we also have a good experience on the ceramic industry as well. And that's one of the reasons you see EOS as being the global leader when it comes to the industrial additive manufacturing solutions. And also we hold a very good position in country when it comes to the industrial AM solutions. So that's the team that we have in India. And our main focus is not just on 3D printers alone. So it is on printers. We have materials that we focus upon. We focus on the processes, because if we do not have a process that is established, having a system and a material is going to make no sense to the entire application development that is happening. So we also focus on the softwares. Then we have the services that comes in place, and also the consultation part, which plays a major role, for which is one of the reasons we are sitting here to discuss on the Printfirm applications and the Printfirm process that we are looking at. These are a fleet of systems that are there on polymers, metal, for various different applications. Possibly if you look at R&D and the small applications, we have these smaller machines. And for production and for the larger applications, we have the larger systems that are there in place. It's just the platform size, and it does not make any difference in regards to the technical aspects of it or the quality that it is going to deliver from any of these systems. EOS works with a complete ecosystem on how we take things forward. So we have external partners, we have startups whom we have funded from the EOS side, and we also have our group companies which have multiple different areas. Yes, please.
Sir?
Yes, go ahead, please. I'm able to hear you.
Sir, please close the pop-up windows, which is located at the lower right corner.
Is it fine now?
Yes, yes.
Okay, sorry about that. So we have a group of companies that are there. So we work with quite a few of the startups.
Yes, sir. Now fine. Thank you.
We have funded, and there are companies like Elementum 3D. If you look at which is only into developing materials. If you look at this EOS group company called Lithos, which we are working with, which is only into ceramic 3D printing. And there are also very specific applications for which we work with, like if you look at this company called Conflex, for developing the cooling channels and also the heat extinguishers. So we work with various different companies to make an ecosystem so that it supports completely for our industrial additive manufacturing applications. And AMCM is one of our company which we work only on the additive manufacturing custom machines when there are specific requirements. Like one of the requirements that I could name is, like, we had a requirement where they wanted to build a component for the aerospace space applications, which was about 1.2 meter in height. So we were still able to get a system which was customized for these companies to get the production done without any kind of delay. So today we're going to be focusing only on the powder bed fusion systems, which is going to be on SLS, selective laser solidification, and DMLS, which is the direct metal laser solidification. Why is it very focused onto these two? Is because we did understand from the survey of Roland Berger that when we put all of these 3D printing technologies together, the powder bed fusion with laser stands on high in terms of the performance and in terms of the output and cost compared to all the other technologies. So that's one of the reasons we were very focused from Delta Rapid 3D to see how we could get this technology into manufacturing side and also into the print firm applications to make it easy for industries and also the academic and the research institutes to adapt into it. Yes, definitely. Earlier it was called as laser sintering technologies. Now it is no more sintering, but because of the patent we were holding on to that. Now it is called as laser solidification. It's just the term that has changed, but in terms of the applications from the beginning, it's still solidification, but just for the patent we had it as sintering. So it's not actually the conventional sintering, but it is solidification. So like in our earlier session, Dr. Dodmani was actually explaining about how we are doing the process of 3D printing, which is very similar. But here we do not have a deposition system, but we are having a kind of powder bed that is spread on a platform. Then the 2D layer of this sliced data comes onto the platform. And after the first layer that gets sintered, we go on to the second layer and it keeps going on. I have a small video which might explain us on how this entire process works on the system. So that is the platform that you see in the middle, and the recoater applies the powder. Then the laser comes, solidifies that particular layer, and the platform goes down, and the next layer of powder is spread, and the process continues. So from powder, we have the laser sintering or solidification. Then we have the final part that comes into place. So this is the entire process, how the technology works on the laser solidification process. So the real-time application when we are looking at for this kind of a technology, it is, we might have a hype of anything can be possible in 3D printing. Yes, that is the market hype that we have of anything is possible. But when it comes to realization, when it comes to actual, when the rubber hits the road, what is going to actually materialize is going to be on this priority. So it's going to be defense and aerospace on the top priority. Then we would have the automotive, health industry that comes in place after that, and also the tooling industry that comes in place. So these are the areas where it has got a lot of adaptation that is happening when it comes to the industrial application, not just prototyping, but in terms of end product that are getting adapted into the system. So these are the areas that we work with on the aerospace, medical, tooling, dental, automotive, and also the industrial applications. Just a brief background of what EOS is into in India. So EOS had its start way back in 1998 when we had our representation office. Then we had our first mission that was established in CMTI in Bangalore for their tooling applications. Post which we had an opening onto the automotive industry on LML adapting to the technology for polymers, and TVS again for the investment casting applications. We have the system where the investment casting applications are developed for various different investment casting applications. And then we had set up our branch office with spares because the number of systems were growing in very rapidly. In 2009, we had a breakthrough in the dental industry, where the dental copings got started to getting manufactured, not just prototyping, but getting manufactured through these 3D printers, which have gone into the end applications. And I'm proud to say, like, one of the dental implant that I have is also a 3D printed one. So we had a breakthrough in 2012 when Honeywell had got their R&D team to adapt into this 3D printing through EOS technology. Then for the FMCG market, the tooling had a bigger advantage. So Vasanta Tools was a company which adapted to this entire technology to create conformal cooling channels inside these tooling inserts to reduce the cycle time on the injection molding process. So that was a breakthrough in 2012. And 2013 and 14, we had service providers like Wipro who came in place. And 2015 was a larger breakthrough for us for a larger platform, because HCL decided that after they approve out for 2 years, they are going to get into this technology with the largest platform that was available then. And then we had a breakthrough in the tire industry in 2016, where MRF adapted this technology. And we had more service providers who were coming through because of the demands that were created on the tooling, the aerospace, and the medical industry that was coming into adoption for this particular technology. So that's how even ISRO adapted the technology to take it forward to put parts and various different components in space. And we had even the quad laser, which was 4 laser system that got introduced in 2019, and various different models of engagements that have happened, like boot model, and as now we are talking about a newer model of print firm also that's coming in place. So while we are talking about this, a couple of case studies for us to bring it from the past achievements that we have done in the space. In 2017, we had this GSAT-19, which took this particular part, which was a feed cluster. We can talk about in the coming slides more on it. And then it was HAL which put this part in place, because Semilac is a qualifying agency that qualified this component for flight for Sukhoi 30, and which was done by HAL, and it is already in flight. And we also had the medical implants getting implanted for the medical industry in India. And the first time all these had happened through this particular technology. There's again a little more explanation on how it was done for HAL on this component. And ISRO actually even took up the entire thing to qualify aluminum for their processes for 3D printing it. That's when we had this particular feed cluster getting 3D printed, because earlier it was multiple different parts that had to be assembled. And when they had quite a bit of RF leakages, which had a bigger challenge in them, having this entire process done. So once we had this feed cluster 3D printed as one, monolithic part, all these challenges that they had in the RF leakages were taken care. And these are the advantages, that this entire 3D printing brings in. And definitely people like Indian Air Force have already certified this process for going forward, not just for prototyping, but also for production. And Navy was also another, area where they had certified the entire process to take it forward for not just prototyping, but production, both on the metal and also the polymer applications. Some of these materials, just wanted to put it across, we have, very few materials that have been listed here, but there are quite a fleet of materials that are available both from EOS and also from third-party vendors, because all our systems are, open architecture systems. So you are able to run both our materials and also the other third-party materials for any kind of research and applications that you look forward for. So one of the reasons why we are looking at PrintForm today is we do understand from this slide of McKinsey, once the component is delayed by about 6 months to reach the production or reach the market, there is close to about 66% of loss that happens to the complete margin that a company is looking at, because of which there is a huge loss when they look at the overall production, and the cost of production goes up. So what happens here is, in today's industry, we need to strike a balance between two of these areas to achieve a particular thing in the entire process of manufacturing. So what we're going to do today is look at how do we achieve a balance between these two to get the final output when we are fighting against this particular giant that I've put it in this column, which we will look into, through which we definitely need the PrintForm support to take it forward. So for us to understand this entire concept of how the PrintForm is going to work out, so we need to understand from the basics of what is the AM technology process. Earlier, if we were looking at the earlier times, 3D printing was considered as prototyping. It was called as RPT, rapid prototyping. And in yesterday's times, if you see, as I told you, it was all on the small batch productions that we were talking about. And it was like part qualification. People were trying to prove that, whether this is a particular material, is it equivalent to, the original material? Is it possible for us to get the right part printed at the right cost? All these were the talk of yesterday. What is today's talk? Today's talk is on ramp up of production. When we are talking about production ramp up, it is quality control, it is, in terms of cost per part calculations, automation, and technology integration, which is the talk of the day today, and which is what the industry wants to directly get into. And yes, of course, we are looking at digital factories in the future, which we have already proven out, and all these systems are capable of Industry 4.0. And that's one of the reasons, because of the caliber that this technology has got. This is listed out as a part of the disruptive technologies that we are talking about today. And why it is a disruptive technology? Because it's a changing technology, changing in terms of going for a betterment. And that's one of the reasons, like, we see 3D printing as a changing technology. So when we look at change in 1900s, if you see the entire street, there is only about one automotive vehicle that we can see, one car that is there. Everything else is a horse carriage. But within over a span of 13 years, if we look at the same street, there is only one horse carriage and everything else is a automotive vehicle that you see, or cars that you see. So yes, of course, if the change then in 1990 to 1913 was so drastic, in today's context, you can see the change is so very drastic that in 2001, the companies which went on as digital were the people who are making larger profits in 2017. And today you can imagine about where the profits have gone about, because these are people who have adapted to the change and adapted to the digitization and digital side of the entire activity. So why am I saying this? Is basically because we are looking at 3D printing, which is not a simple technology, which is a digital technology. And why is it still not having that kind of an impact? Is because we are in that innovator and early adapter stage. We have moved from the innovator to the early adapter stage. And what is happening today is we are trying to move from the early adapter to the early majority in the market. So when we are trying to move from early adapter to early majority, you can see there's a chasm and a gap that is there, which is becoming a bigger challenge for the industry to get in from early adapter to early majority. This is exactly where we are looking at how Print Farm could support the entire initiative. And if at all the Print Farm could support the entire initiative, it has to be through the entire process of the research and development, and also in terms of the knowledge transfer, which we are going to look at. That is one of the reasons we are pitching in here on the Print Farm approach on a whole, to bridge this gap or a chasm that is there. So to understand this, we did a survey with over about 500 different companies to understand what is the gap that is there and how this gap could be bridged. So out of all these 500 companies, close to about 47% of these companies, they said the bigger challenge for them is the overcoming the knowledge gap. So this knowledge gap is become the bigger chasm or the gap for them to transfer from the early majority to the early adapters. So when we are doing that, they are looking forward for this kind of technology knowledge transfer. How do we select a particular part? Because part selection becomes a very important aspect in the entire approach that we look at. So when we select a particular part, how do we build a business case? This is all becoming a knowledge gap for the industries to get into the adoption of 3D printing. So we thought this is going to be an area where it could support the industries through the Print Farm to help them to adapt to it by supporting them with this knowledge gap, by transferring the knowledge and taking things forward for them. So we wanted to understand the 3D printing process chain. Yes, of course, we have the idea being the first thing in place. Then we have the design place that comes into, once we have an idea, we make that idea into a design. Then after we have the design is when we go for 3D printing. And finally, we have the post-processing. So earlier what happened was there was a misconception where people thought if we buy a 3D printer, we have the complete know-how of 3D printing, which is not the truth, because in my next slide, you would understand why what I'm saying is right or wrong. I repeat that 3D printing is, buying a 3D printer is not going to be a complete solution for us to know the process of 3D printing. The reason is because this slide explains the actual value chain of 3D printing. Yes, we have the idea where we have the STL file. Then we have the second aspect of it which comes into place. It's the digital transformation. Under this digital transformation, if you look at, we have the part screening. As I mentioned to you earlier, the entire knowledge gap is because this portion of it is missing. What is this portion? How do we select the right component for 3D printing? Is every part a suitable candidate for 3D printing? Yes, there is an hype which says like anything can be 3D printed, everything can be 3D printed. But when it comes to the actual reality, not everything is 3D printable. We need to be selecting the right component for 3D printing. If we don't have the right component, finally, like we are going to go to an end saying like this is not a viable technology. So we need to have the right component selected. Once we select the right component, is it possible to achieve our goal by directly 3D printing it, or do we have to go ahead for some design change that we will have to do? Design for additive manufacturing. Once that is done, that is not the end of it. We need to look at how we prepare this data before we send it to the machine. So once we prepare the data, we simulate the part to find out what is the time it is going to take, what is the kind of build volume that is required, what is the kind of quantity of material that is required, and what is the kind of support it needs to be generated, and how much is the quantity of support it is going to take in. And we get a complete build simulation done and a cost per part calculation that is getting done even before we look at printing anything at all. Only after we finish this, we look at a printer, how we can get things printed. And after we print it, we have the post-production where we have the heat treatment, polishing, surface finishing, smoothing, all the grinding and things that comes in place. So when we look at this entire 3D printing value chain, where is this knowledge gap? Where is that knowledge that is there? 10% of the learning that is there on the idea side, and we have close to the majority of it, that is the 60% of the learning that comes on the digital side of 3D printing. This is exactly what is missing out when we are talking about the gap from going from an early adapter to the early majority. So when you look at the rest of 3D printing, what happens in 3D printing is only about 20%, because whatever the best data that we have, if we are able to throw it onto the machine does the job perfectly fine and gives you the output. If we feed in a bad data onto the machine gives the bad output. So the entire learning is happening on this area, which is close to about 60 to 80% of learning that is happening in this particular place. So this is very important for us to understand and how we can grab into this, even before we look at it. And then we have, once we have this particular knowledge in-house, we don't have to be worried about a printer, because we have the EOS print farms that are available, which can definitely support us in terms of printing it, which have a fleet of machines inside these print farms, which will help us to bridge that entire printing activity, because printing is just about 20% of the activity. But in today's context, what is happening, most of them are putting back the industrial 3D printing or the backseat just because they think investment for this entire thing is going to be very large, which is not the truth, because our maximum amount of learning, close to about 80%, is on the digital side, which is the digital transformation that needs to come in place. And printing is only about 20%. So we should not be looking at 80% of investment, leaving out the 20% of the investment. So I'll come to this on a detailed way in my coming slides, which will explain that to us. So what is this digital transformation that we are talking about? What is there into it? So when we are looking at part screening in the digital transformation, we need to be evaluating the technical fit of a particular component. Let's take this component, for example, which was a space application for which we had done. So when we had the first technical evaluation done, the component was not having a very great technical fit. So for us to get the technical fit, we need to find out whether it's the right AM system is available. Does it fit into the right AM system? Do we have the right material that are available? Does it fulfill the AM design rules, this particular part? So once we decide on that, we try to fit and see where exactly it fits inside this particular boxes. So our aim should be, from the lower technical and lower economic fit, we need to be pushing the component to a higher technical and higher economic fit. So when we look at the economic fit of the application, how high are the production costs? What are we saving in terms of the supply chain? And what is the value addition that the entire AM process brings in? These are very important aspects that we will have to be looking at. So once we are looking at this, we also decide to know and understand what is the business case that we are able to develop for this industry from this particular component. So because this is exactly what the industry is looking at in today's context, to help them to move from that early adapters to early majority. So where we would be helping them with the technical economic fit and giving a business case generation for them to move the entire thing from a low technical fit to a completely high technical fit by giving this metrics to them, from adapting the design rules and optimizing the design to coming back to this particular kind of a design, which is having very high efficiency compared to the older kind of conventional way of looking at a particular component. So this is exactly what we look at, and finally what we achieve is a transformed component from a chunky part to a very 3D printable component, which gives a lot of viability for the industry. So when we are doing this, there are also other challenges that comes in place. The biggest challenge would be the supports. Support is actually a kind of blessing in disguise. We cannot completely remove support, because supports are needed for us to take care of the thermal stresses and distortion that comes in place when we are doing the building. But we cannot have too much of support, because that is going to affect our post-processing, and also it is going to cost us more, because we are using the similar materials also for the supports here. So what we do is, how do we optimally get these supports generated? So we need to make sure how we support this entire activity by optimally looking at the supports. And then we have the DFAM of once we finalize, how do we do a design change, which we already saw in the earlier component. So a little more detail on the DFAM. So probably this would be one of the orientation that we could look at in terms of building a component. So what happens is, like, if we do it this way, you have a lot of these green areas are supports that comes in place. So you have multiple different supports that are there. So you try to optimize a little bit, and you get into this particular kind of a configuration where you have a little bit of lesser support. Then you still adapt things into the entire design. So where you have removed the support maximum, is that the best thing? No, still we have more kind of options available where we can vertically build it to get this kind of a support. And once you make even that structure a kind of self-supportive, we are completely removed from all the supports that are there. So that's the kind of DFAM that we are looking at. And from there, we can still move forward to these kind of various different DFAM processes that we could support the industry with. So these are areas that helps us on the DFAM side. And then from DFAM, we also go into trying to find out how many number of parts we can build on one build, because this is also going to help us in terms of getting a business case done for the industry when we are looking at industrial applications, because industries would be very particular in terms of us giving them that know-how of what would be the cost per part. For us to achieve that, we need to know all these details of how many number of parts we will be able to build, and how many builds, and what is the kind of system that we are looking at. All these play a major role, because if you are only going to do about one part, if you look at this slide, it says about 4 hour 15 minutes. But in the same way, if we are doing 5 parts, you can see it is not multiplication of 4.15 into 5, but it is 5 hours 14 minutes only. So this is the reason why laser bed fusion system is adapted for the manufacturing side of entire thing. So if you're looking at the complete build, you're not looking at 1 or 2 parts, you are looking at 374 numbers. This is in our larger frame system. And you are looking not about multiplications of 4 hours into 374, but rather it's only about 44 hours. And what is the material required? And the unused material is also refreshable. So these are advantages that we bring in to build a business case for the industry. So that's one of the reasons. If you see the LEAP engine part, which is a very well-known part, you would have understood it was 20 different parts that were welded together and made it. And because of this entire process of adapting the digital side of it, and helping to understand what are the DFAM options that could come in place, they were able to lightweight it by 25%, and the efficiency was pushed up more than 15%. And that's the kind of the applications that we are looking at for the industry. And we try to get them this entire know-how of how they actually can look at the cost per part calculations. So what are the tools that we are going to look at here when we are focusing on the build challenges? through the digital tools. Yes, we are going to have these data preparation tools that comes in place, and orientation, slicing, and cost per part, and build calculation tools that would come in place. And we play an upper role in terms of becoming the consultancy for the industries to adapt these kind of technologies. So this is going to bring in a balance. What balance is it going to bring in between? As we were discussing, it's going to bring in a balance between the quality and the cost, which is very important for us as we are fighting against time. Because industry today is fighting against time, because that is the gap that they have on the knowledge gap of how to play between the quality and the cost to when we are fighting against the time. So this is exactly where the print firm concept is going to help them, because system is something, if we are looking at 3D printer alone, this is something that anyone can manufacture, anyone can build a system. If there is a right funding, everyone can build it. And if there is the right, material is always available for us to put it on the system. So what exactly is the role which helps the industry to move from that early adapters to the early majority is the process that is involved on how we play between the system and the material to achieve the right process for them to go into this end result. So when we have the right process and the parameters, and when you know how to play between the system and how the machine interacts with the system, we have the quality that comes in place. Then once we have the quantitative result that are there in place, we are able to address the price which get reduced. And these are the areas that are coming in very, very, very importantly for us inside this digital transformation area. So this is going to be a game changer for the industries to move ahead on adapting to the industrial 3D printing. And we would be helping them as the research institutes and research educations by utilizing these print form concepts to select the part for them, do a DFAM for them, and create a business case to see how they can have very high technical fit and very high economic fit of various different components that are available for them with these digital tools that are available for us. So with this, we would also be having different AM training concepts that comes in place. And there will be multiple different trainings that would be there in innovating with 3D printing. What are the fundamentals of metal and polymer 3D printing that are there in place? And how do we do part screening? These are all various different trainings that would be part of it. And in the later stage, we will also be having on DFAM, lattice structures, parameter editing workshops, melt pool monitoring, which would be one of the very important area of research, because we need to know how the material interacts with the when the laser is there, and which is going to be one of the big important areas of researches for us to qualify various different newer materials into it. And then definitely we would have the other areas that comes in place, which would play a major role on the adaptation that we are talking about through print firm. So looking at all this is definitely, earlier, if you had seen the entire digital tools and the hardware, it was both together. So if at all somebody had to get into 3D printing, he or she had to buy the hardware to also have the digital side of it to get into 3D printing, which was a huge kind of budget activity, which had a challenges for adaptation to take a longer time. So in today's context, what has happened with the print form model and the digital print form model is we have got the option of separating the hardware from the digital tools. So we don't have to spend the entire 100% of the capital thing on with the machine, but rather less than 50% of the investment. We are able to get the complete digital tools for us to play a major role in terms of helping the industry to adapt to the 80% of the need that is there in today's context to build the gap that is there for them to move forward. So we have these digital tools which are going to be the major role players to take the industry forward in terms of adoption. So by this, what happens is the digital transformation and the print form adoption happens through this, and we have the knowledge transfer, the training and the consulting and business case that is getting developed. And once we have the component developed, you don't have any worries about where you get it printed, how you maintain the systems, where will you put the systems, because print form takes care of all these. Once you have the ready data, you can shoot out the data to the print firm. And what happens is the print firm gets the components printed at a very attractive machine hour rates for us and gets it delivered back into your hands. And you are able to get it into the industry's hands at a very short span of time, because you don't have the challenge of how you're going to maintain these machines, how you run this machine, who is going to operate the machines, and what would be the costs. And all those challenges are taken care because we already have these MHR rates ahead of us. We don't have to depend upon any kind of an external person to support us in terms of this business case development when we are working with the industry that we are talking about. So that is going to help us in terms of achieving this slide that I was showing to you about. So what is this digital transformation and print form concept that we are talking about? So what this digital transformation and the print form concept is looking at is to train and set up this kind of center of excellences along with the digital tools inside the institutes, because institutes have the capacity and the knowledge to transfer this knowledge to the industry. And that is where we find this expertise of academic institutes and the research centers having this expertise. So we wanted to establish this center inside the academic institutes with these design tools and training which would be conducted on part selections, the training on DFAM, and there would be a couple of in-house printers also that would be available for the development activities that would come in place. And then we have a complete access to print form. So when we have this complete access to print form, what happens is like EOS team, which is having the expertise for more than 30 years, will also jointly support us with the internal team that is there to develop, select the parts, and also create a business case and get the component qualified and printed from the print farm and deliver it back into your hands to achieve the concept of helping the industry adapt the industrial additive manufacturing initiative. So that this is exactly how the entire process of print farm concept is going to be looking like. So what is there in print farm alone? I mean, when we talk about the farms that are available with EOS, what we would have is we have a fleet of systems that are there on metal. We have a fleet of systems that would be there on polymers. And I mean, the list is very minimally mentioned here, but there are multiple different systems and also multiple different materials that would be available, both polymers and also on the metal. And we are also adding in the ceramics also that are coming in place in our print firms. So this gives a complete access for us to materialize on the industrial applications that are coming or which are not able to move forward because of this knowledge gap that is there. So what is the scope of this entire print farm? Yes, what does it give it to us? It gives an easy entrance to industrial additive manufacturing without the large capital investment, because we do not have to be worried about looking at large capital investment to get into 3D printing. It gives an easy entry for us and to help the industries to consult with them and to take them forward in their applications. And then it helps us with data protection. What is this data protection that I'm talking about? So when we have this print farm that is there with us, and when we have these digital tools in-house, what happens is these digital tools, when you're working with these digital tools and when you're exporting the data to a print farm, you know, these data can be encrypted. So when I say encrypted, what happens is when you are doing a development activity with an industry, the end component is not just the IP for this industry. Your design is going to be the IP. how do you protect this design? Because once you lose out this design to a service provider or a print firm, what happens is you are exposed and you get vulnerable on your IP, because all the activity that you took in terms of developing this component, in terms of redesigning it and getting the right support generated, everything comes to a stake because it is in somebody else's hands. So we need to take care of the data protection. How do you do that? So when your data is encrypted and when you're sending it to the print firm, it only is an execution data. It is only a job file that comes, and the print firm cannot read your data. It is only a printable data. So once you shoot it out to print firm directly downloads it onto the machine, and it can only print the data and give it to you. So this kind of encryption helps in terms of data protection, especially when we are working on development products with industries, because industries are very particular in terms of signing MOUs and signing NDAs in terms of the data protection. And here in this case, it gives a complete data protection. In fact, we can even go ahead without any challenges of losing out the data. So that is a major advantage that we have. And we also have the other advantage in terms of digital inventory. In today's context, if at all you get a project from across the globe, you don't have to be worried about it, because we have these print firms that are spread across the globe. So even if it is from any other part of the world, you have this digital inventory through which you can store these data. And the same activity, you could do it to our print firms that are there in any location where your customer is there or your industry is there, and we can get the components printed and even delivered it there, which gives you an access to the technology across the globe with the digital inventory that we are able to take care with the print firm that is there. And of course, it gives a complete access to the print firm. When I say the complete access, let's imagine if we push hard with the management and try to get a budget for one particular metal system. So what happens is we are stuck with one particular platform for the next few years until we prove out to the management that this is a technology that is bringing in the right kind of development or the vision that we are looking at and focus towards. And if at all we have the similar kind of applications or that size of applications that we are able to get from the industry, we can take it up. And if at all there is a larger application that comes in, the entire investment that we have done for that system goes on stake, because we still have to depend upon an external vendor to get this done, because our machine size is not enough for us to take it forward. So what we do is we give this complete access for 3D printing, the printers on the print firm, which gives you a complete scope, not just for one particular platform, but gives you access to complete different platform of multiple different materials and multiple different size of machines, and both on polymer, metal, and the advantages like we are also having ceramics that are coming into place. And not just that, on the digital tools that we have in-house, that is going to be in-house, we will have the option of digitally accessing all these systems for us to do a cost per part calculation, simulation, and everything. We will be able to do it at our system that we are sitting across across the table to work upon, to access all these machines digitally or virtually, to do a complete simulation, to give even a clear-cut business case to an industry to take forward their additive manufacturing initiative. And of course, yes, definitely we will have an MOU signed in terms of having the attractive MHR rates that we mutually be agreed upon when we are looking forward on the entire initiative of print firm concept that we are looking at. So this is going to be the print firm where we are going to take a complete advantage of that 80% of knowledge transfer that will be happening through us, through the Center of Excellence that would be coming through for this entire print firm activities. So how is this initiative looked upon? Or how is this print firm concept going to be executed? It is going to be executed through the Center of Excellence and authorized training centers that we are looking for. So what is this Center of Excellence and Authorized Training Center going to be looking at? So there are going to be two sides of it. So there's going to be initiative that is going to be taken up from the EOS side, and there's going to be initiative taken up from the institute side. So what are the initiatives that we are looking at? Yes. So we are going to be having the digital team that would be equipped by the EOS team to take up this entire applications that are there, or all these kind of challenges, the industry challenges that are coming to us, and there are various other industry challenges that are, industries are looking at. We look forward to offload all these kind of challenges onto these kind of centers or center of excellence that are coming forward. And we also encourage the institutes to also bring in these kind of initiatives, because we would be having this digital team that would be equipped, and we will have a small setup also with the metal and polymer technology internally, which is going to help us in terms of looking at the challenges on how we are going to take the industry forward with these challenges that are there. And these trainings are not just going to be for the colleges alone, but you can also extend these trainings. We expect the institute also to the center of excellences and the authorized training centers also to extend these trainings to the industries to move forward in the adoption. So when we do all this, what is the end result that is being looked upon? Because we want to see a sustainability in the entire process that we are looking forward. So when we are looking at a sustainability in this entire process that we are looking at end result also that we want to see. What is this end result that we are looking at? Definitely, we want to see a sustainable model in terms of revenue generation in the entire process. So once we have this revenue generation that comes in place, the entire center of excellence becomes a self-sustaining model for us to take the center of excellence from one phase to another phase on a self-sustaining model. So once this center is also established, because we have the trainings and also certified trainings by all these OEMs who are going to be part of this entire initiative, we have guaranteed placements that comes in place, and we can definitely see new entrepreneurs and startups that are coming in because of the entire initiative that the institute and the center of excellence along with the authorized training center would be taking forward. And with this entire concept of COE ATC, which is going to be for the print firm, we definitely have a recognition that is going to come in place for the institutes that are going to take up this entire activity. And definitely we look forward to meet the vision of the country in terms of the digital India and the industrial 4.0 initiative that is coming in place, because this concept is completely focused towards the digitization of the entire technology and the digital transformation that comes in place, because a print firm concept is completely a digital transformation concept that we are looking forward for. And this is exactly what the complete concept of print firm with Center of Excellence and Authorized Training Center is going to be looking like. And what is the process of getting the entire thing done? So it has got 4 different steps on how we're looking forward to get this done, which is already into action of 2 levels of selection that would happen with the Center of Excellence form that would be available, and then we would have there's a campus visit to understand the kind of infrastructure that the institute has got to take this entire initiative forward. And there will be an MOU that would be signed as a second step to take this entire initiative forward. And the proposal would be customized in terms of seeing how it can fit into the existing structure of the institute to take this entire initiative forward, and through which there would be also this setup that would come in place with an investment that would be part of this entire activity. So this is exactly the print firm concept that we are looking at. There was some of the customers' names that had come in place, and so this is exactly the Center of Excellence with the print firm concept that we would be looking at. And this is the complete thing on the print firm that I would wanted to share with you today. And thank you so much for your time and attention. So probably if there is any questions, we can definitely look at this and on the questions if that are there.
Enabled with the mic. You can ask. You have raised your hand. Professor Krishnan. Mr. Saravana Kumar is asking about does any college or university in India established 3D print form center of excellence? What is the initial cost needed to set up the digital print form?
Okay, thank you for that question, sir. So yes, I would not be able to give you the complete detail because, as I told you, it would also be on a customizable way based on the kind of evaluation that is done on the on the institute's capability that is existing as of now. Because what we are looking at is not just a sustainable model for the center that is going to be coming up or with the center of excellence of additive manufacturing and print form, but we are also looking at the existing capacities. Like you might also have some of the softwares that are already available with you, and some of these post-processing equipments also that are already available with you. And we also look at the entire process of how, even by getting into the center of excellence, your complete facility that is available internally with you on the softwares that are available and also the post-processing equipments are also utilized for this entire activity. So this entire concept will be customized based on that complete engagement. But on your previous question in terms of has anybody got this entire thing set up? Yes, there are already a couple of them on the pipeline, which would come to a closure very quickly. And it's open as of now. So we are looking at early movers to get the best of the advantage of this print form and the center of excellence concept.
Good evening, sir. Hello?
Yes, good evening, sir.
This is Satish Kumar. And then I need some list of functionally graded materials which can be printed through 3D printing.
Sir, you can definitely reach out to us on these areas because there are researchers that are going into the FGM areas where we can definitely support you on that. Probably that would become an entire subject altogether to discuss on this platform. So definitely we will support you. I mean, my contacts are also put up there, or you could reach out to the organizers and they could definitely help us to get in touch with you to take the requirement forward.
Yeah, and then in 3D printing, the major drawback is the time we are fighting here, as you are told. Nowadays, the researchers are going on the single 3D printer can use the 2 or 3 nozzle to print the entire body. So that is that efficient enough to print the material by using the 2 to 3 nozzles, sir?
Okay, well, one thing, let me clarify to you. Here, the technology that we are talking about is not on the nozzle-based technology. Here, we are talking about the powder bed fusion technology altogether. So that's one of the reasons when I showed you the initial slide on how Roland Berger has said powder bed fusion systems are the best adaptable technologies for industrial additive manufacturing is because we don't use a nozzle to 3D print the entire component, but we use lasers. So we have a platform on which the powder is spread, and then the CAD file is transferred and we use a laser. So it functions in a magnitude faster compared to any other technology. So that's one of the reasons we have these kind of technology getting adapted more for getting the throughput. We even have multiple laser systems that are there in place instead of nozzles. So we have multiple lasers that come in place to get the efficiency of the production. And the recent thing that I can say is like it's not we are not talking about just 2 nozzles or 2 lasers or 3 out with a system which is 1 mil lasers, which talks about the production to be on a next level in terms of adaptation for the industry to be made it easier.
Yes, sir. And you also talked about the ceramic materials that can be printed. When you are going to print the ceramic material, there is a difficulty of it is breakable. Ductility plays a major role, so that it is easily breakable. How you are overcoming that difficulty so that ceramics can be also printed?
Yeah, so what we're doing is for the ceramic 3D printing, that's the reason I had put it in bracket, because ceramic 3D printing that we are doing is different technology compared to the metal and the polymer that we are doing. So ceramic 3D printing is going to be based out of the SLA kind of technology, where we have the resin and it's in the molten stage, and we start printing out from these resins, so through which we are able to achieve it. With the same powder bed fusion system is not used for ceramics. So it's the lithography system that is used for 3D printing ceramics, so through which we are able to achieve it.
Yes, sir. And suppose you have talked, sir, I have a little bit knowledge about that supports, but what I'm asking is, without that support, what will happen to that part? Is that can be the hardness or strength may be affected, or the entire part may be affected, sir?
This is on the ceramics that you're asking about, right?
No, sir, general, yes, general.
General, okay. Yeah, see, on the on our polymer systems, so if you take the EOS polymer systems, we don't have supports at all. There is no supports, because our powder itself acts as supports, and the entire component is built without supports, because after you print the part, you shake the powders off, and because powder takes care of the support on polymers. On metal, we definitely need support. So on the metal, what happens is we have done studies, and our customers have proven out that they can build, we were earlier claiming that we can only build parts without support up to an overhang of about 40 degrees, which is already disproven. And we are able to build parts with an overhang of up to 20 degrees also, and without supports. And today's context, there are case studies that I could even share it with you, where our customers have built parts completely without supports on the metal as well. But we do advise that there needs to be support, because support plays a major role in terms of the distortion, and also in regards to the heat dissipation that happens. So supports play a major role. So that's where I was mentioning that supports are a blessing in disguise, because we need them, but we do not need them when it comes to the economics that are coming in place.
Yeah, sir. In that, if you are going to print the same material or same part again and again, why can't we go for with that bed? The same supports can be placed ideally, so that we can print easily, so that we are not the post processing work may be reduced. Is that possible?
Yes, definitely. You see, one of the case studies where we had done an automotive two-wheeler, light heat sink, you would have seen this case study on the internet, where we are already able to do that kind of a stacking and building the entire, part by optimizing these supports. These are all part of the entire digital activity that I was telling to you about in terms of the knowledge transfer, where we will be able to, transfer those kind of knowledges for us to, help the industry to adapt to it by optimizing the entire thing. If it is a smaller component, if we are able to build multiple components, how can we stack it also by optimally getting the supports done for them to go in for production? It's definitely possible.
Yes, sir. When coming to pipe design, if you are going to design a pipe internally, if the flow we can achieve in at the internal part of the pipe, how can the tolerance to be maintained so that the flow can be free flow, a laminar flow like that?
You're talking about just a plain pipe or that to be printed, or what? I didn't get you on that.
Yeah, plain pipe, sir.
See, one thing when we are doing a part selection, that's where I was telling about, we do the right component selection. Because if we are going to try and just do a plain part, which is going to be of a pipe, which might not bring in the value addition of 3D printing, because it would be definitely cost, effectiveness will not be there, because we have a normal pipe, we could definitely get it at a cheaper cost than getting it 3D printed. So we need to be sure about why exactly we need to select this component into 3D printing. If it's just a simple pipe, it doesn't make us a technical and an economic fit for us to go with 3D printing. So first of all, we need to know that, because as I told you, we are not in that initial stages of understanding whether it is the technology is going to be, proving out in terms of material properties are there, or is it a viable technology? These are not the questions that we are looking at this point, because these are all proven out, and that's one of the reasons you find these kind of components already put in space. And since last 4 or 5 years, these are components put in space not just by some global company, but people like ISRO. And these are components that are functioning to its maximum capacity compared to the conventional parts, and which proves out that if we have the right components selected, definitely we will be able to achieve these challenges that are there.
So there is one question from a chat box. Dr. Ilangovan is asking about what do you predict the future of material printing to be, organ and food printing?
So, it's definitely there is a future in terms of there are quite a lot of companies who are looking at in those areas also on the development side. But it's still on that initial stages. Probably I might not be the right person to comment on it, but to our understanding, it's still not a mature technology like what we are looking at in terms of aerospace, defense, automotive, and medical. Yes, medical, where we are talking about is on the implants and the medical tools, which are going to be of a greater adaptation by the industry immediately. But definitely it has got a future and quite a bit of researches that are there in place.
Maheshwaran is asked about is it possible to add fibers in between a metal to make it as a metal composite in laser technology?
Fiber on the metal, is it? I do not
Yes,
know why we would need a fiber, kind of.
He's talking about metal composites. Metal composites.
See, on our
laser technology.
plastic polymer machines, we have these composite materials that can be 3D printed. So that is where we have a particular material called alumide, which is actually a composite material which has got 50% of aluminum and 50% of metal. So this we printed on our polymer machine, but on the metal machine, it's completely metal. Because earlier we were talking about materials which were not which were actually having porosity, and there were density challenges and things like that. Because we were using a high melting alloy and a low melting alloy. So when we were looking at these micrographs, there were a lot of these challenges. So we had to have these kind of reinforcements that were coming in place. But in today's context on the metal, if you talk about titanium, it's complete titanium that we have. So we have the densities are like somewhere at 99.9% dense. So these are actually very strong materials that we are talking about, and the bondage is really good. So any material that you take on metal, we don't look at this kind of reinforcements or fiber things that are there. But we definitely have composites that are there available on our polymer machines.
Participants, do you have any other questions? Satish Kumar.
Yeah, sir. Sir, I agree with you when you are talking about the pipes. When it coming to a medical application, whereas we can print a heart valve or something in the some medical tubes, so that in that part the precision should be very high. So that is that possible? That high precision can be achieved through 3D printing.
Yeah, I can give you a couple of examples on this. See, I was talking to you about MRF using our system, and people like Asanta Tools using our system. What they do is, like, when you look at tooling insert, these tooling inserts have conformal cooling channels inside. So with this conformal cooling channels play a very major role when we are looking at the entire process of 3D printing for tooling applications. So when we are talking about conformal cooling channels, conventionally what happens is they drill holes, straight holes, to get cooling channels done. So when they're doing these drill holes, it does not reach out to the ends of the insert. Because of that, there is no even cooling that happens. So the cycle time is longer, and the cost of the manufacturing goes higher. So what we do is, like, we 3D print the entire insert. If you had seen my video in the initial stages, so that is actually an insert. So inside the insert, we have conformal cooling channels which runs very close to the walls. So because of this conformal cooling channels, what it is actually reduced very drastically, and the cycle time is cut down, and the cost per part is like drastically dropped down. So because of which industries are already adapting to the technology, because these conformal cooling channels are definitely possible. So these conformal cooling channels that I'm talking about are very fine conformal cooling channels, which are already been possible to get done. And in fact, like where if you had seen the nozzle that I had shown to you initially, so this nozzle also has got multiple kind of cooling channels that are there inside, and we are able to get this printed without any challenges. And it's not just for R&D application. As I told you, these are things that I'm talking about for end application, where customers are able to utilize it for their final output. So these are all having internal cooling channels in these nozzles, which we are able to achieve it. And it's not an assembly, but it is one monolithic part that is printed. So you understand, like, what is the kind of channels that are running in. And in fact, like in the tooling applications, it is still further complex, where we have these conformal cooling channels running very close to the walls, circular in various different areas based on the requirement that they have. So it is definitely possible, sir.
Yes, sir. I strongly agree with you. When you are coming to a medical application, there is a limitations in materials. That's why I'm asking, sir.
See, on the materials, what exactly is the material that you're looking at? Because the reason is we have materials which are medical grade, which is titanium. We have cobalt chrome is another material which is a medical grade material that we have. These are the major requirements, because in today's context, what is possible is the medical implant, which is a bone replacement or a craniomaxillofacial kind of application. These are applications that demand for a lighter material, and which has to also have the kind of strength that it requires, like a bone. So we have already been able to successfully do things on titanium and also on cobalt chrome. There are additional more materials that are getting added up as well.
Yes, sir. Thank you, sir. And one last question: how it will 3D printing will impact the watch industry in future, sir?
I would rather put it this way: it's not about future. It has already impacted the watch industry, and that's one of the reasons. Like a couple of the very high-end watchmakers are already in touch with us for developing these applications for them. And the reason is because some of these high-end applications, also high-end watches, they look at 3D printing their internal components with materials like gold, silver, and platinum. And having these kind of precious materials also part of our portfolio, we are able to even meet up to their requirements on the watch industry as well. So it's not about how it's going to affect in future, but it's already affected, and we are already working on with various applications for them as well.
Yes, sir. The 3D printing technology that can be the knowledge sharing can be an easy one. Even ordinary man can understand. That is what the 3D technology leads through us. But when you are coming to research industry, when you are having an expert in that industry in that thing, he's inventing a new thing also. It going to reach a common man very easily in 3D printing technology. So that how the expertise can survey in this particular 3D printing thing, sir.
I mean, that's exactly what I said in the beginning itself. There is a hype in the market that anything can be 3D printed and everyone can do a 3D printing. Yes, but what is the kind of application that we are looking at? If we are looking at real-time industrial application, it is not a game. I mean, it's a serious industry that we will have to work with, because materials come in place. You need to know what is the right parameters that have to come in place. You need to know how the melt pool is actually happening there to understand and get the right parameters out, how the laser actually interacts with the material. And if you are replacing an existing component with a newer 3D printable material, is that material suitable for your end application? So all these a common man would not be able to do unless it is an education institute or a research person, a scholar who is getting into the entire initiative. So it's a collaborative effort between the business development team and also the technical team of the institute to take this initiative forward. So it is not just a simple thing, and definitely requires quite a high level of technical expertise there.
Yes, sir. To be frank, now the engineers what they are maximum. So to be frank, now we.
So sorry, I'm not able to hear you.
Yeah, sir. To be frank, when you are coming to a job opportunity for mechanical or something called other engineers, the thing where CNCs and other things, or even high class 10th grade student can do the ordinary thing, so that the engineers are going through the jobless. So now you are telling that that's I am agree. The laser printing and other things are it needs to be expertise in that area, so that if in future at least in future or after the technology is normal to all the people, that the expert is going to replaced by the ordinary people. That's what I am asking, sir.
See, here we should not be kind of integrating two things. You're trying to integrate two things together, which might be have to be looking at in a different angle altogether. Because see, there is an area where the application development and the parameter development, all of this comes on the digital side, which requires high technical skills that is needed. So this is what I was talking to you about, the 80% of know-how and knowledge, which is very important, which is what I was mentioning. If I can pull that slide out for you, where I was talking to you on the areas which are going to be of greater technical requirement, would be in these areas where we have the technical skills that are required. So what you are doing is trying to integrate this technical skills along with what is going to happen on the printer. See, the operational skills of a machine is going to be easier. Operating a machine, because it's nothing but a machine. It's a simple machine. You start, you know how to plug in. where to feed in the data. That's it. The system is going to take care of it. This operational skill is not going to be expensive. So this is definitely going to be there available for people who do not even have that expertise. But on the technical side, in terms of taking up this digital transformation thing, is going to require high levels of skill at this point of time, because it's not a very old technology that we are talking about. This is a new technology that is disrupting the entire industry. So it's definitely going to take a longer time for that kind of a comparison for you to get it done, like how you're comparing it with the CNC industry. And that is way far ahead, and which is going to take time. So what are we talking about? Are we talking about the technical skills in the entire process chain of 3D printing, or are we talking about the operational skills? That matters to us.
Yes, sir. Thank you very much, sir, giving those answers.
Thank you so much, sir.
I think no more questions.
Perfectly fine, sir. Thank you so much for your time, for me also to be a part of this. And thank you all for staying till the end. Hope it was a good session for all of us. So you can definitely reach out to me or to the coordinators and organizers for any further clarifications. Yes, sir. Over to you, sir.
Thank you, sir. So this is the time for Thanksgiving. On behalf of the management and the Department of Mechanical Engineering, Dr. Mahalingam College of Engineering and Technology, Pollachi, we would render our highest thanks to Mr. Daniel Amos, Director, Delta R&D, that is a company in Bengaluru, for the wonderful session talking about the print form and other related activities which are happened in the print form technologies. Thank you very much, sir. I also thanks the participants who have participated in this session. I hope you have got elaborate exposure on print forms, 3D print forms. Thank you, sir. Thank you, one and all.
Daniel, sir, thank you.
Thank you so much, sir. Thank you so much to all your team, and good day.
The feedback form I already posted in the chat box, so kindly fill the feedback form. We will